In this video, let's review derivatives of inverse functions. So recall from your algebra or pre-calculus days, you get an inverse by switching the x and y and then solving for y. That's how you figure it out algebraically. The notation for an inverse is this guy right here, f to the little -1. This is read f inverse of x. The notation for the derivative of the inverse is f inverse prime of x. You can verify algebraically that functions are inverses of each other because they have the following property. If you compose the function, if you put the f inverse into the f function and clean it up, you're going to get x. Likewise, if you put the f function into the f inverse, clean it up, you're going to get x. We can use this formula to develop a formula for our derivative of our inverse. So as long as we do the same thing to both sides, algebraically it stays the same. So in this case, let's go ahead and take the derivative on both sides. d f inverse of x d dx, taking the derivative with respect to x on the left, take the derivative with respect to x on the right. Well, on the left side, we have a composition of functions. That means we have the chain rule. And the chain rule says that you take the derivative of the outside function with the inside times the derivative of the inside function. So it's going to be f inverse prime of x. And the derivative of x with respect to x is just 1. All right, so this factor is the derivative of the inverse. That's what we want to solve for. So if we divide both sides by all of this stuff, we'll be left with f inverse prime of x is equal to 1 over f prime f inverse of x. All right, there's the formula that we're going to use. Looks a little complicated. It's really not too bad. So a couple more notes about inverses. You know, you switch the x and the y. So if you have a function evaluated at 1 and you get 4, then the inverse evaluated at 4 would give you back 1. Graphically, the inverses reflect over the line y equals x. And we'll see the relationship in the derivatives after a few examples. And then last thing we need to think about is we're working with inverse functions. So an inverse function is going to be passing the horizontal line test. So we might have to have a domain restriction. So sometimes we can work these algebraically. In this first example, that's not hard to do. If I wanted to find the inverse of this function, I would switch my x and y and solve for y. So let me do a little bit of algebra here. We have 2y is equal to x minus 3 divided by 2. And we have y inverse is equal to 1/2 x minus 3/2. If I wanted to find the derivative of the inverse, y inverse prime, well, if I just use the power rule, that'll just give me 1/2. 1 is the exponent here, so 1 times 1/2, and then we subtract 1, so it's just 1/2. Okay, so that's one way to do it. When you have a nice, easy function. Normally, they're way harder. So let's think about it using that formula. Here's our function, and we want to find the inverse at 9. So we want to use the inverse derivative formula to evaluate f inverse at 9. Well, if our inverse evaluated at 9 is going to equal something, then our function evaluated at something will give us 9. So you see how that works? Our x's and our y's are just switched. Okay, so we got to figure out what is that something. So we can take our function, which is 2x plus 3, and set it equal to 9 to figure out what that something is. If I subtract 3 divided by 2, I believe that would give us 3. So So I'm going to come back in here. Let's see if I can erase this. We know that something is a value of 3. Okay, so what does that mean? Well, let's come back to our formula. I have 1 over f prime of f inverse, and we're evaluating it at 9. Well, all of this f inverse of 9 is equal to 3. So let's make a substitution. 1 over f prime at 3. Well, what is our f prime? Let's figure that out. If our function is f of x equals 2x plus 3, then f prime is going to be, well, f prime of x would just be 2. Because if I use the power rule, I have an exponent of 1. 1 times 2 is 2, and then that goes away. So our derivative evaluated, f prime of 3, there's no input, there's nothing to plug in, is always going to be 2. So if I make the substitution in the denominator here, that just gives me 1 over 2, which is the same value that we got working it algebraically. So it's not too bad if you have something nice and simple, but they are never going to last that simple. Okay, so we jump right to a quadratic. So let's write down our formula. The more we write it down, it's 1 over f prime of f inverse of x. And so here's how I think about it. This is what we're trying to solve. F inverse of 5 is equal to something. F of something is equal to 5. Let's figure out what that something is. So we set our function equal to 5. Let's solve for x. Add 3 gives you 8. Divide by 2 is going to give you 4. When you take a square root, and here's what I was talking about earlier. Normally you're going to have a positive and a negative. And that's fine, except for if we have an inverse function, we need to restrict it to just the positive. All right? Because this is a quadratic, shifted down 3 vertically stretched. There's the function. If I were to draw the inverse, think about the inverse function is going to look something like that. That is not a function any longer. So we have to just have one of the pieces, and therefore we're restricting the domain. So we're only going to look at the positive. All right, so we know that that something value is 2. So let me come in here. We know this is going to be 2 now. All right, that is this y value right here. So I've got 1 over f prime of 2. Okay, so now we need to find the derivative and evaluate it at 2. If your function is 2x squared minus 3, well, my derivative, f prime of x, is going to give you 4x. F prime at 2 will give you 4 times 2, which is 8. And so this just gives us 1/8. So that wasn't too bad. Let's try another one. This time we have a 4th degree, no way. Algebraically, I'm going to solve for the inverse. Let's just go ahead and use our formula. So let's write it again. 1 over f prime of f inverse of x. This is what we're solving for, the f inverse prime of -1. So f inverse of -1 is equal to something. F of something is equal to -1. We've got to figure out what that something is. So x to the 4th minus 3x squared plus 1 equals -1. All right, so if I move that 1 over to the right, x to the 4th minus 3x squared is equal to -2. So let's try some things. Let's try 1. Does 1 work? If I plugged in 1 for my x, I would have 1 minus 3. What do you know? That's -2. And just a word of advice, most of these will work out nicely. If you're not allowed to have a calculator, I want you to try 0, 1, -1. possibly 2 or negative 2. But usually something small and easy is going to work out nicely for you. Okay, so I'm going to make my substitution. I know that that something is now 1. Okay, so let's find the derivative. F prime of x will give us 4x cubed minus 6x. What is f prime of 1? Well, 4 times 1 cubed is 4. 6 times 1 is just 6, and so that's negative 2. So this initially was 1, and the derivative evaluated at 1 gave us negative 2, and there it is. That is the f inverse prime at negative 1 is negative 1/2. Okay, let's do another example. This time we don't have a function, we just have some stuff. We've got if g of 2 is 5, g prime of 2 is 2/3, g prime of 5 is 3/4, then g inverse prime of 5 is what? So a couple of things, we're working with g's now, so I'm going to write my formula in terms of g. So g prime of g inverse at 5 is what we're looking for. So g inverse of 5 is equal to something. G of something is equal to 5. So look at what you've got. We know g of 2 is equal to 5. So that something is no longer a something. We're going to name it 2. Okay, so 1 over g prime of 2. Well, g prime of 2, that's also given right over here. And so that is equal to 1 over 2/3. Well, the reciprocal of 2/3 is 3 over 2. And that wasn't bad at all. I got one more problem for you, and that's a table problem. We haven't seen a table problem yet, so let's work one of those. So selected values of a strictly monotonic function, gx, and its derivative, g prime of x, are shown below on the table. And I went ahead and wrote out the formula. Find g inverse prime of 1. Okay, so just like before, g inverse of 1 is equal to something. G of something is equal to 1. So we've got to figure out what is that something. So g, and we want something to be 1, so that would be negative 1. If I plugged negative 1 in for my something, I get an output value of 1. So this something is no longer a something, it's a 1. We named it. Okay, let's plug it into our formula. So I have 1 over g prime of 1. Well, what is g prime of 1? Okay, so back to our table, I have an input value of x and a g prime. I just messed that up, didn't I? That's supposed to be a negative 1. Let's just double check my work. Back up for just a second. My input value, what's going to give me 1 on the output? Negative 1. That should have been a negative 1. Okay, I'm back on the right track. All right, so now the derivative at negative 1, I'm almost back on the right track. There we go. The derivative at negative 1 is equal to negative 1/5. 1 over negative 1/5. The reciprocal of negative 1/5 is negative 5. And that's my answer. Okay, let's try one last problem here. The inverse negative 3 is equal to something. So g of something is equal to negative 3. So I'm looking for an output value. What input's going to give me an output value of negative 3? That's 4. That's my something. So get rid of something. We just named it 4. Okay, so now 1 over g prime of 4. Well, g prime of 4, g prime with an input value of 4 is negative 2. And so really not too bad. There's my final answer.